Welcome to the ADF Insider. This session is about classical mistakes with the Oracle Application Development Framework Internal APIs, Part 2. My name is Frank Nymphius, and I'm from the Oracle Application Development Tools Product Management team. In this two-part series, we talk about common mistakes as we see developers doing them while learning or progressing their skills in the Oracle ADF framework. In Part 1, we talked about specific API mistakes in the framework itself, the use of internal classes which you shouldn't. We talked about accessing the binding layer. We talked about creating a new row and how to do it properly and right so that the binding layer gets aware of that. We talk about controller mistakes in terms of redirecting and extending the controller exception handling. In this second part now, we're focusing on the view layer. We look at expression language mistakes, we look at the Java surface and components confusion, and we looked at the JavaScript mistakes as we see them most commonly done when working with the Oracle Application Development Framework. To do mistakes is a very human thing, and it's the way that we learn. This is how my kids learn, and this is how developers learn. It is more important to understand the lesson you learn and be happy to go back to some code that you've written in the past to apply what you've learned to improve even code that you have in the application running for a longer time. However, even if doing mistakes is a very human thing, don't abuse this privilege. Don't bend the framework only because you can. Don't look for kind of short-circuiting the framework. In other words, don't fight the framework. Always go with the framework, try to understand how the framework works, and try to apply the best practices that you can find. Let's have a look at expression language. So may I introduce Dom. Dom is an engineer, very smart and always looking for new ideas and new ways to code things. And he's very clever in understanding the architecture. For better readability of his source codes, especially the expression language within the pages, he decided to prefix everything with the scope it's in, which is a pretty smart idea, because this way, from just looking at it, you can clearly tell for how long a specific object in memory lives. However, he seems to have a problem, and the problem is that prefixing a managed bean with the scope, especially if it's a servlet scope, which is request, application or session, he sometimes has the experience that a null pointer exception is thrown. So it's not getting the information he wants. So in the example that he's giving on the slide, he's trying to read a last name of a person from a property in the managed bean in request scope. So why is that not working? Well, it doesn't really work always. Sometimes it does, sometimes it doesn't. The reason for this is that the managed bean object is a facility of the Java Services framework, which means that you have to reach out to the framework to get the managed bean instantiated and copy it into the memory scope. If you directly use request scope dot managed bean name and then the property you want to access, you're directly looking up the hash map in memory for that object. Now, if this object hasn't been created before, then it wouldn't exist in the memory and thus returning null. If instead you're accessing it without the prefix, then the Java Server Faces framework will be challenged with the task to find the object. And given that the object has a configuration in the Faces config file or in the ADFC config file, if you use the task flow, then it's the framework that sets it up for the proper scope in memory. It creates, instantiates the bean, loads it up, and then makes it accessible. The confusion comes from the fact that by ADF controller specific scopes, like view scope, page flow scope, backing bean scope, you explicitly have to put a prefix for the scope in front of it, just for the framework to find the bean that you're looking for. And the reason here is why it works is because the ADFC controller takes care of the managed bean instantiation. So the controller, the ADF controller, which is an extension of the Java Server Faces managed bean facility, intercepts the call, looks for a view scope, page flow, or backing bean scope mentioning in the expression language, and if it finds it, doesn't first look into the memory, but challenges the managed bean framework. If the bean doesn't exist, it will instantiate it. So this prefixing of scopes for managed bean doesn't work for the servlet scopes, but it works for all special focuses and scopes that are added with the ADF controller. Coming to Java server faces. Immediate chew is a very popular theme on different forums when people experiment first with Java server faces. In this scenario, DOM wants to have a button that, when the button is pressed, should update a text field. Of course, this text field already contains a value. So some user types something in, and then dependent on some other conditions, DOM just wants to override what the user did, maybe concatenating the user information in the field with what should be prefixed for the string. So the example he's giving here is, he has a command button with an action assigned to it, and the command button has immediate set to true. And immediate, as you know as Java Server Faces developers, just short-circuit in the term of the button the request lifecycle, and for other components where you set immediate equals true, just make sure this component is called first. To understand how Java Server Faces works, we need to have a look at the 6 phases of the request processing. When the request first comes in, it's restoring the view. That is, it synchronizes the incoming request with the server-side state that is held in the component tree. If the component tree doesn't exist at this time, then it will be created. With a request, if it's a returning request for a specific page, there are request values, though they're not hidden because they are in a post scenario where they're not showing in the URL. The request values are applied to the component state on the server. Once validation is successfully processed, the values that you send to the component are set to the local representation of the component, so no longer part of the subnet. In the following, the model is updated, and then invoke application will fire all kind of actions, even if this associates a navigation, so navigation would happen there. Last but not least, the response of the change is rendered to the client, so the client sees the changes on the page. It is important to understand that immediate equals true doesn't mean execute only, it means execute first for many components. There's one special case, which is the command button, but because if you use the command button, what happens is that if you have immediate equals true, then all the phases after apply request are not continued. Instead, it goes straight to invoke application to invoke the action on the button, and then concludes with render response. The use case when you want to use that immediate equals true on a button is for a cancel button or for navigating away. Within the JSF lifecycle, in a more complex form, we see the Oracle ADF request lifecycle being part of it. So still we have the 6 request lifecycles that the normal JSF requests run through, and then you see that's highlighted in red. There are specific ADF lifecycle events that help us to prepare the model to make the data available to query the business service so that you can work with ADF. And as you can see, bypassing some of these steps also have an impact to the ADF model. So if you bypass process validation, update model values, and go straight to invoke application, then nothing will happen on the binding layer because you've more or less bypassed it completely. All that would happen is the binding context would be created, so it's available when you run immediate equals true, so you can access the binding context. And how you do this is how we explained in part 1. The model is prepared, which is of course required just to make sure the data is correct for the page that is requested. And then in the end we render our page as we do in Java Server Faces. Within this process we do have metadata commit. Now this metadata commit is used for customization and personalization. So any change that the user does on the user interface for personalization won't be committed to the repository if you skip the the invoke application phase. Yeah, so if you would go straight to render response in your request handling, which you can, it's just in any of these phases you can listen for, you can just call phases context render response, and then it goes straight to render response. In this case, metadata wouldn't commit. So let's have a look at the example just to give you a more lively view on what the problem here is. Coming back to Dom's issue with not being able to override in a command button what's typed into an input text field. This is a very simple use case, as use cases should be simple. So let's put a message in here. Just say the classic hello world. So I have a button immediate equals false and immediate true. So let's see what happens for immediate equals false. For immediate equals false, the button overrides the text that I put into input text field. Let's do the same for immediate true. Now press an immediate true, and you see nothing happens. So still the value is set for the text field. The question is, why does it happen? So let's have a look into the phases that are executed with each of the requests. So first, let's execute hello world with immediate equals false. What we see here is that all phases of the request phase that I introduced before are executed. More interesting is to look at the text field values. So there are two types of values for a component. The value is a local value which later on is submitted to the model and updating the model. The submitted value is what comes in from the text field on the client side, and this one overrides the local value. So here we have a text field submitting the value hello world. Then it runs through the apply request value phase, still keeping the submitted value. It runs through validation, and in the validation phase, so after process validation, the text field value hello world now is passed to the local value, and the submitted value is null. So it's cleared out, the component is ready to take new input. Then we run through the model input update. So this is where usually we would update the ADF binding layer if that was a ADF binding bound text field. At the end, invoke application. This is where we set the value, the local value, to hello world. So we're overriding the default value for that component. You see the text value now is hello ADF insider after invoke application. So when we render the response, we see hello ADF insider. Now let's do the same with immediate equals true. Hello world again. First of all, you see that the request phases are a lot shorter. So it's kind of shortcutting. As I mentioned, the button is a very special use case for this. So it runs through a store view. It has a text field value empty, and the text field submitted value also empty. Then there's the apply request values. And in this apply request values, it's now attempting to set the value to hello world 2010. Yeah. But given that the text field value still holds, or the submitted value still holds hello world, though the local value holds hello ADF insider 2010 as we set it here, it's overwritten. So that means that when the response comes back, the text field hasn't changed because the submitted value never got cleared out. So the text component itself is holding it on to its own value. So this is a special use case of a button. If we had a input text field with immediate equals true set, now what would happen there is if you have 2 or 3 input text fields and one of the input text field is set to immediate true, then the confusion among developers is that they think that this behaves similar to like the button case where the component that has immediate equals true is the only one being executed in the request. Now this is not true. Now what happens is this component is executed first and the others are followed. So if you have 3 text fields, 1, 2, and 3, if the first has immediate equals true set, then this will be processed right after apply request values. Then the normal processing continues and the others will follow. If you want to short circuit the request processing, you just want to operate on just one field, maybe to perform validation on that field without impacting the others, without submitting the whole thing, then what you can do is you set immediate equals true, but then within your value change listener code, you will have to call faces context render response just to short circuit and prevent others from following and updating the model. Let's go back to the slides. So one you want to put on a t-shirt also is immediate equals true doesn't mean partial submit equals true. Or on the same side, partial submit equals true doesn't mean immediate equals true. Partial submit is a functionality in ADF Faces that allows you to submit specific, or a component, I should put it that way. Partial submit means you're submitting a form and then using partial triggers you decide which component on the screen should be refreshed after that. So that means you're not redirecting the page just to show the new values, if there are any, based on the outcome of the partial submit operation, but you just point to the specific components that you would think that they have changed so that the user sees this change without that the page reloads. But immediate true, which is a JSF functionality, and partial submit are two different things. They're not related. ADF Faces component mistakes. Well, the most obvious is mixing JSF and HTML. Again, Dom learned how to create layouts the old markup way, and he's used to have HTML mixed on the pages just to get the proper layout that he wants. However, it seems to break ADF Faces because more often than he wants, he's not getting the layout that he really is going for and aiming for, but instead the layout screws up. Well, the truth is that HTML only theoretically works in JSF. JSF 1.2 definitely improved the ability of JSF developers to use HTML markup for the layout rendering, but still the request processing of markup is not the same as JSF. And though JSF 1.2 tries to synchronize the two, still HTML does not really feed into geometry management if this is handled by the JSF components as it is in ADF Faces. HTML binds to JSTL, which only supports immediate expression, so it's not really supporting deferred expression. So that's wrong on the slide here. So immediate expression is what the JSTL supports. So that means that all the data needs to be available to the time that you render the page. ADF Faces rich client components handle geometry management. This might conflict with HTML because the component itself looks at its parent containers, see what space is left for it to lay out its children, and then it performs that. Now if HTML is in the picture, then it can't tell exactly what the spaces it has available, and based on this miscalculation or misassumption, the layout might be screwed. HTML elements also don't participate in partial page rendering, which means that there's a problem on your side to refresh an area that lists markup elements. So if in response to a specific action in ADF Faces, you want to refresh a specific HTML area, this doesn't work. So the recommendation is, don't mix and match. Things are getting better in Java Surfaces 2.0, as it's always getting better with the next release, but Java Surfaces 2.0 changes the view declaration language, which currently is Java Server Pages, which clearly is not really made for the JSF request lifecycle, and they change it then to Facelets, and Facelets is a lot more markup friendly, allowing you to really put markup into the spots, create templates with HTML markup that then would allow you to do the proper layouts you want. But still, it's always a risk to mix static markup with dynamic ADF Faces components. Here's an example. Pretty straightforward. On the left hand side, a tree is built the proper way, just using ADF Faces components. The tree iterates over the ADF Faces components, just stems out the tree nodes, and everything shows nice. Now what Dom wanted to do is, Dom wanted to, within the node stamp, use the markup table, the HTML table, just to nicely align the node values, and this failed. As you can see, the data is not rendered there. You can always try Trinidad, the Trinidad component set, because the Trinidad component set has this kind of table layout as a JSF component, in which case the whole table layout would go into the JSF request lifecycle. To enable the Trinidad components for an ADF Faces project, all that you need to do is just right mouse click into the component palette listing all the ADF Faces components, choose Edit Tech Libraries or Manage Tech Libraries from the context menu. This opens a dialog, and on the left hand side you find the Trinidad HTML components. Once you shuttle them over and close that dialog, you will have a new entry in the component palette on the select list, which is for the Trinidad HTML component. And there you find a table format, row format, cell format. This would allow you to put, for instance, a table layout into a component of ADF Faces, like a tray or like a column in a table. Yeah. So that's much more better use to use Trinidad than to go with raw HTML. As you can see in the picture, it just doesn't render. Inline style sheet. For as long as we do or did HTML markup, we're told that use style sheet, which is the best practice for color coding components on the page or how to enforce a specific look and feel. And so developers attempt to do the same in Java Server Faces and ADF Faces, of course. Well, in Java Server Faces, in most of the cases this works because Java Server Faces reference implementation components are pretty straightforward and very simple components. So an input text field really is an input text field. Well, ADF Faces is a bit more complex than that. In our example here, the AF input text field consists of a label area and of an input text area. So if you style the inline style property with a background color to be red, out of sudden you see that the background color is applied to the label, but not to the text field. This is confusing to Dom, but good enough Jim knows an answer to that. Because ADF Faces components are far more complex than simple HTML elements, styles are applied to different areas of the component. But by default, the inline style applies it to the root DOM element. Now, in the worst case, the root DOM element could be a div. Just a div element with no attributes, no properties, which means you're just applying it to the whole thing instead of the specific area you want to apply it to. For some of the components, like input text field, Oracle ADF Faces provides an additional property called content style. Now this content style then will operate directly on the content of a component. In our case, that would be the input text field. So if you use content style for your background color, then the text field itself will be colored with a red background color. However, best practice is to use skinning, which is a framework in Oracle ADF Faces that is also available in Apache Trinidad, that makes sure that by skin selectors, which are really comparable to style sheet selectors in HTML, that with skin selectors you can directly access a specific component within an ADF Faces component. The input text field is a very simple example. Now think big, think tables. A table is a very, very complex component. If you look into the HTML generated source for a table, you will see it's a construct of nested tables, diffs, span elements, and so on. Yeah. So if you want to skin a specific behavior of a table, then style sheet won't do. So you're just applying style sheet to an inline style property or a style class just doesn't do the job because of the complexity of the component. So have a look at the skinning framework, which is explained in the Web Developer Guide. Get familiar with that, and you will be able to really put your colors right in spot to where you want to put them. Nesting tables. That's a very popular one. People trying to build master detail relations by just putting a table as part of a column in another table. So this is what Dom is trying as well. He's just like blindly copy and pasting the master detail relationship into the column as a table, runs it, and is terribly surprised what the outcome of that is. Well, Jim has an example here on the slide where he, knowing that having nested tables won't work at all with the ADF Faces Rich Client components because of various reasons, he optimized the scenario. So instead of just having the master detail relation expressed purely by the view link, he created a tree binding for this master detail relation and used the tree binding to create the embedded table. So as you can see, there is a table column, and within this table column he just adds another table, and this references the child data of the parent record identified by the row value. The row variable is a variable automatically created when you drag and drop an ADF bound table, and that is kind of stamping through the different rows. So even within this optimized use case, so Jim avoided just doing the obvious thing, just dragging and dropping a view link related view object as a detail. So he's doing it right, but still it looks very awkward because the whole layout is kind of messed up. It's not really the layout that you would have expected. At least the row currency works, but that's all that does. The reason why this doesn't work is that the table itself is a component that does its own geometry management. So the parent table looks at itself and it's stamping its rows. It's not really creating objects for each row. So that means that the layout is decided once and not for each and every row. Now if you put another table in there, then this table tries to do its own geometry management. So it's just looking at its parent component, which happened to be a stamped column. So not even the table, it's a stamped column. And then it tries to guess what is the best way to lay out. So it's unpredictable and therefore not recommended to do that. So nested tables is not recommended and not supported in the rich client component set. And you see even with the scroll bars how badly that looks. In summary, not everything that compiles, and surely what I showed on the slide before it will compile, can be shipped. Another confusion is AF for each and AF iterator. And the two are really often confused. Both actually do similar things. They're iterating over a set of data to produce layout content, component output based on what they find in the iteration. However, the AF iterator is an ADF Faces component specific feature that behaves like a table without Chrome. So it, like the table, stamps the children. Now this means that if you iterate over 15 records with the AF iterator, it's not creating 15 times the number of objects, live objects on the client. Instead, it just renders the markup for the first row and then it uses the same to stamp out the values for the rest of the list. This is very efficient, this is very performant, and definitely the way to go. In addition, it can use the JSF data model as well as the trial collection model, which also is very nice because you can directly hook up to the ADF binding. The child items that you have can also have access to a parent. If we take the example of a table, every table row object basically is contained in the variable row. As I mentioned, it's a default that we create when you drag and drop a table. Now, this object can be accessed through hash brackets row. Yeah, so you can access the content of the object that stems a row within the AF iterator. On the other side, the AF for each is just a replacement of the JSSTL for each, because this doesn't support any sort of variable status, so not giving you any kind of impromptu information about what's the current state of the component is, which is very important if you work with JSF. This one only iterates over Java util lists and doesn't support collections. So if you want to hook up to a collection, you first have to transform the collection into a list, because otherwise it won't work. Usually you use this AF for each component to generate the content of a select list. So if you dynamically want to compute the fSelect item for a select list, then you iterate in an AF for each just over a list of items. The components that are laid out by the AF for each are remembered by the index, so not by any sort of row key. So that means that if in the AF for each case, dynamically within Java, you remove one of the child components that are printed by this, then the other one would just move up, which means now that the index that this component had before now is assigned to another component. And that can be very confusing if you rely on the index as an identifier for a specific component so that you can directly access it, because after the first change in the printed components on the page, this is all messed up. Yeah. For this reason, items that you create for AF for each should not be added or removed or reordered in any way. The use cases that you use AF for each for, which is really what it's made for, is that you want to create real components on a page, maybe ADF regions, by iterating over a list. And this then should, for instance, conditionally print specific layouts, like instead of having the what I mentioned before, the table in the master detail, which doesn't work as an inline table, you might want to build your own view-only representation of a nested table. Yeah, by using an accordion panel, and then for every accordion panel, it's a master section. In that you will have another table. So for this you could use I for each, though the table would then be read-only. But that would be an example on how to use that, just to build a layout that exists out of components. So let's see, Dom has another issue. He's again trying to build a nested table, but still it doesn't work, and now he's really becoming angry with us. And let's see what he's doing. Now, this time what he's trying is, he built a table, and as I mentioned before, just drags and drops the dependent view object as a collection model into that table column. So now he's relying on that the table will have some sort of row currency setting while iterating over it. Well, tables, and it's documented pretty well in our documentation, are rendered on the server. So we talk about stamping, yeah, because the table always uses the same component artifacts to make the table very lean and fast performing on the client. We don't create client-side object for all of the table rows. Instead, what we do is we just iterate over the markup that is generated for the table and just stamp in the new values. For this reason, the children that you add into are not iterated over. So if you drag and drop a table into a column, then what happens is that for the first row, this gets evaluated, so you see the children, but then it's repeating the children. So it's not that for every row that you have in the parent table, the children will look differently. For this you would use a tree binding, as I had in my optimized example before. So this won't work, and that is the reason why it doesn't work. If you need some sort of nested layouts, you can always use A for each or AF iterator. One of the examples where A for each is used, if you drag and drop a dynamic table from the ADF context menu, then you will see the AF for each being used to look into the page into the view object definition for how many attributes the view object has, and then it creates one column and column renderer component per each of the attributes it finds, so that dynamically you can define the size of the table in terms of the number of columns. This is one use case for where we use A for each out of the box. Otherwise, it's preferable to use AF iterator instead. Well, now Dom learned a lesson, and still his use case is to have something like this, where the detail information from a specific row on the table is displayed within the table. Can he do this? And of course he can, because otherwise this screenshot would not be happened. The reason that for this to work is because it's not using a nested table within the table, it's reading the detail information of the child components when stamping the table. Now that also means that none of the names you see in the employees column is selectable. So all that this is, it's a context information to give for a table row. So we know that in department 40, Susan Mavericks is working there, it's human resource, Matthew Weiss is working there, and so on. So we have additional information. So how do we get additional information from the children into the rendering of the parent table without creating nested tables? Because most of the time, all that we are really interested in is just the context information. To do so, first of all, you create a tree binding. To create a tree binding, and this is shown just next to the screenshot sitting to Jim's head, you just drag and drop the table, then you go back to the binding configuration, so there's a binding tab on the bottom of the page. You select the tree binding that got created for the table, open it using the pencil icon, and then you select the default the view, so in our case that was department view, hit the green plus button to choose a dependent child. In our case this is employees. You select then the information you want to show within the context of the rendered table, and that's it for once. Now have a look at the structure window that you see on the left hand side. First of all, the table has a variable equals row. So this is iterating over every row in the table. And now see me look using the AF iterator. So in the AF column employees in the structure window, you see a TRH table layout. So I'm creating a table layout, non-functional table, but just a display table layout as a child of a column. And this table layout has an AF iterator. And this AF iterator iterates over the children. So its value is row, so it's accessing the parent row variable dot children, which means it's looking for, is the parent row having any dependent children, and then it's iterating over it. And then what it does is it prints a row layout, and within the row layout it prints the cell format, and within the cell format then it looks for the attributes, first name, last name in our use case here, to print it out. The AF iterator has the variable name list, which means that to reference the first name and the last name, as you can see in the structure window, it uses list.firstname, list.lastname. So this way you get exactly this output. Yeah. So we are running the application, the parent table gets printed, and while it gets printed, the row object is accessed within the content of an AF iterator. The AF iterator passes this information to its internal variable, which is list in our case, and then stamps the detailed information. And this is how you do this. So you can get detailed information easily into a table without dragging and dropping the detailed table. And in many use cases, this is exactly what you want to do. The other day, Dom came with another problem. Whenever Dom is opening a pop-up dialog, actually the pop-up doesn't come up, though he's using exactly as documented the AF show pop-up behavior, just trying to do it right, but the pop-up is never ever started. And this is the code fragment that Dom sends us in. So there's a command button, fair enough, you need some sort of command to open a pop-up, and this has a show pop-up behavior. So we see the pop-up ID, referencing the pop-up to launch, the trigger type, which is action, which is good. If you set the trigger type to click, which I often see as well, then all that would trigger the pop-up to being open would be a mouse click. So no tab navigation, then hitting enter wouldn't work. So if everything should work, every way that a user can access a button and perform the action on a button, you want to set the trigger type to action, not click. So if this rings a bell, just revisit all your pages and change click to action. Anyway, he's aligning it after end with a specific component with a text field, so that's fine. So obviously nothing wrong in here. Well, the reason why this doesn't work is not really easy to spot, because it's easier to spot something wrongly used than something missing. In this case, it's information missing. Pop-ups must be open, if they're lightweight pop-ups, using partial submit. It's a lightweight dialog that is part of the rendered HTML page. Now, if you don't use partial submit for the button, what will happen is that while you submit the button, the page is re-rendered. So the whole page is redirected to itself, which in the attempt of creating the pop-up will just redirect the page, and the new page does not have the pop-up rendered. Yeah. So here what you want to do is on the button you want to set partial submit equals true. Another problem Dom faced the other day. So in his application, Dom has the requirement to upload files, and there is a file input component that allows him in ADF Faces to upload files. But then it works in a normal JSPX page, but as soon as this very same code and the same managed and everything is put into a page fragment, it stopped working without any exception being thrown. So it is confusing to Dom, and Dom is really unhappy these days. So he sent this in to Jim, and Jim had a look. Well, the thing to know about this is that to open up a pop-up, there is a setting you have to do on the AF form tag. The ADF form tag is rendering the HTML form around all the input text field on a ADF Faces page. So what you need to set there is users upload equals true, because otherwise the multi-type is not set and there's no way to upload a file. A region, however, doesn't have an ADF form, but participates from the ADF form tag, or uses the ADF form tag that is in the parent page. Now, if this ADF form tag does not have the user's upload set, then the same functionality that used to work in a JSPX page doesn't work if added to a page fragment, because just this little missing information. And if an ADF region is a part of another ADF region, which is a part of another ADF region, which eventually is a part of a page, then you have to go all the way up just to check if on the parent page the ADF form tag has users upload set to true. And this is a very common mistake we see. Last topic for this recording is JavaScript mistakes. As you know, you can use JavaScript within ADF Faces, and we provide a very rich client architecture for using JavaScript. Still, there's something to know about that. Well, Dom came from traditional web application, and he's really an expert in JavaScript, because this is, I guess, how most of the traditional web applications developer grew up with, just using JavaScript to make things nicer and at least have some sort of animation or functionality on the client side. So this turns for him to be being an expert, and Dom being his corporate nickname, and James Dom being like he refers to himself. Well, what he's experiencing is that he's using a cancel event an update with Dom, which is a functionality which he wrote to access a field, an ADF Faces field, and set its new value. So you press a button, and on the button that you press in ADF Faces, what you want to do is you want to override the client side value of a ADF Faces component. So what Dom is doing first, he's canceling the event. That means that the browser press action in ADF Faces will not be broadcasted to the server, which is good, because if there's no need for the server to do anything, you don't have to go to the server for that. But then what he's doing, he's looking up document get element by ID, which is just looking up the browser DOM tree, and is passing in the ID of the component with a double colon and content. This information was easy to find for Dom, because he was just looking in Firebug, see what is the generated outcome, and figure out that input components typically have this double colon content to identify the area where the user put in data. So he's setting the text field .value, you know, those that understand and know HTML and know that there's a value attribute for the text field in HTML, and he's just setting the value. Now this works perfectly fine, and he's quite happy. But then he met Jim, which is our smart developer, and he said, well, there's a problem with what you're doing there. First of all, accessing the browser DOM operates on the HTML markup, on the generated HTML markup. Given that you're not in control of the markup that gets generated by the ADF Faces components, because this is part of the internal renderer implementation, it might be that the markup is changed without you noting. Or if it's changed, it even might lead to your functionality to break. Now what if for some specific reason the double colon content was changed to double colon my content? In this case, all the JavaScript you wrote just stops working. HTML also doesn't allow you to hook up the area of the component you're going to change to either broadcast a partial page request on the client side or consume a partial page request. So that means that as you're really working on the static generated HTML, you have no control, because what you're not working on is a component, you're just working on the output of a component. Yeah. A better way is to use JavaScript as it's supposed to be used on the ADF Faces client framework. The example in this box below shows you the exactly same code that Dom wrote for the direct access of the browser DOM. The difference is that the component itself is looked up using ADF Pages page find component by absolute ID and just the component ID. So in this case a text field. If that text field was in a naming container like a dialog, you would have looked it up in as naming container ID colon IT1. Yeah, but that would be pretty much the same you would have to do in the browser DOM lookup, because then the ID will automatically change of the component. Best practices, by the way, is to have the ID never hard-coded in JavaScript, but just have a dynamic form of looking it up. And we will have a recording soon on ADF Insider about purely how to use JavaScript in ADF Faces, where we cover all this, where we explain to you how to do this. So just watch out for this recording, which will show on the ADF Insider page within the remaining of the year 2010. And then in the same example, we just said text field set value. But as you can see here, we're working with a client-side component. So we have a client-side representation of the component. We're not working with HTML markup. So no matter what happens to the component rendering, it will always work. Yeah. So there's no reason why it ever should stop working, because you're talking to the component and not to the rendered output. So that's one thing to keep in mind. Never ever, in the context of ADF Faces, use the rendered markup. Don't use document and find component there. So don't access the browser DOM. Always go with the architecture. Well, he learned the lesson, and a day later he came back to Jim and said, well, I tried what you said, but it just doesn't work. So should I go back to direct DOM manipulation? So let's see what he's doing. So DOM is actually executing ADF page find component by absolute ID. Now that's exactly how we recommended it to do, but that always returns null. Looking at the page code, obviously in the first place there's nothing that you would say, okay, that's definitely wrong that you do. So here's a button. The button has a client listener attached to it, which is the ADF Faces way of assigning Java Server Faces events and component events, and it's associated with a type of action, which means that it always fires when this button is pressed, be it with a keyboard or with a mouse. But again, as I said on a previous slide, if something is wrong within a page fragment, it's a lot easier to spot than if something is missing, and in this case there's something missing. What Jim knows is that ADF Faces is performance optimized. So that means that not all components that we generate are really components as objects on the browser. So we rendered the components as a mixture of JavaScript objects and HTML generated on the server. Now every component that doesn't have a specific behavior doesn't need to have an object representation on the client. A text input field doesn't need to have an object representation. A table might have object representation, and it mostly has, because it allows you to swap columns or resize columns. So this is a behavior that requires smart clients, and this is where automatically the JavaScript object is created. But still, for instance, for a table, this JavaScript wouldn't be created for the table cell renderer, be it an output text component or an input text component, nor would it be created for the column itself. Yeah. Panel splitter, they do have an object representation on the browser because they can be moved, so they do have behavior. Input text field, output text field, they don't have behavior and thus don't exist as a client-side object. Now if you want to access the client-side object, not accessing the generated markup, then you need to make sure that an object gets created. And one way to create an object, and this is what I said is the missing information in the example, is to use a property client component equals true. Here you see on the input text field that client component is set to true. Now this at runtime will create a JavaScript object on the browser side in addition to the generated HTML, so that you can access this through the architecture. As mentioned, this is built in on purpose to improve performance, rendering performance when you run heavyweight ADF Faces pages. So don't blindly just put client component equals true on all of your components just to be on the safe side, because this will just contradict what we designed it for, performance on the client. So Jim recommends to DOM always ensure a client component exists, and there are two options that a client component exists. One is set a client component equals true, and the other one is to have the client listener tag attached. So in the previous example you saw that the command button had a client listener tag attached to listen for client-side events. This implicitly creates a client-side object for the button. So the button can be looked up on the client automatically as soon as there's a client listener attached. If there's a text field that has a client listener attached that listens for the value change event for the component, then this input text automatically will have a client object representation and can be looked up in JavaScript. So whenever you face the problem of properly using the ADF Faces JavaScript client architecture, but you see that the object that you're looking for doesn't exist, and you're pretty much sure that the ID that you're looking up is correct, then have a look at the client component if it's set to true or if there's a client listener attached to this. And as mentioned, there will be a ADF Insider session on JavaScript pretty soon, and it's all done. It just needs to be recorded, and that should be published within this year 2010. So as said, Dom is really smart. So what he found is that with the default Oracle calendar, it's not really what he wanted. So he wants to have his own calendar being opened in the context of the component. So he's looking into the Oracle provided JSS libraries. So he's looking into the ADF Faces impl jar file where he finds the JavaScript libraries that are shipped with a product. And there he found a method, as we printed up here, that he just needed to change to call window open and then launch his own JavaScript dialog and return the value to the proper framework variable. So this way he's now getting his own component open. So whenever there's a need for him to start a calendar and to have his own calendar, what he's doing is just getting to the Oracle library classes, and JavaScript files are really patient, so you just open them up in an ASCII editor, you change the code, put them back into the jar, and then your classes will be used. Not everything you can do is what you should do. And we had this in part 1 of this session where we said that things are designed for a reason, but may be bent to do others as well. But never use components outside of what they're designed for. In this case, changing the JavaScript libraries, the default component libraries, is a recipe from Hell's Kitchen, because that brings you into trouble pretty soon. So avoid the heat and just go with what the framework provides. If there's anything you're not happy with that you need to change, just go trigger customer support, file a service request for an enhancement to, for instance, allow a component to behave the way that you need it. And if this is a common, very popular enhancement request, then we're not looking away, we just look into how we can implement that for sure. If you change the JSS library files that are shipped with a product, this is a very safe path to disaster, because as soon as there's a new patch, of course the library files will change. And even worse, if internally the JavaScript libraries are changed, if there's an additional dependency created, then the risk is that your little hack that used to work in a previous release stops working right now or just causes damage on other component functionality. This, however, then wouldn't be supported. So you're getting into locking yourself into something that you started in a little hack, and that turns out to bring down your whole application. So never do that. Always play fair, play by the rules, file enhancement requests with customer support, because this is what customer support is for. On a side note, as we find most of the things on OTN where people kind of reporting problems they have with a component, like this dialog issue that came up there where people want to have their functionality which they were missing, people tend to think that OTN, the forum, the public forum OTN, is a good way to file bugs or enhancement requests, where in fact it's not. Of course, it's very well monitored by Oracle Product Management. We pick up a lot of things from there, and we have very good contributors, ACE directors that send us an email if they find something interesting on OTN. But the proper way of filing enhancement requests and bugs is through customer support, because there's no guarantee, and you don't see any flag being set or any acknowledgement. There's no guarantee that this, what you report on OTN, is picked up. OTN is a community of users that help each other, monitored by product managers that also provide you hints and tips. For now, this is it. So we have 2 parts of common problems as we see them on OTN, just reported, and different recordings on the ADF Insider side. Of course, there will be more, and we're looking out for more. Chances are that you will see us coming back to this topic with another session on this Insider about classical mistakes. For now, it is what the most common mistakes are that we observed on the OTN list, on the internal mailing list, because there are a couple of things we get internally as well. So how do you learn more now that you have a better understanding of what not to do? On the OTN webpage, or if you go to oracle.com, if you prefer that, there is a product page for Oracle JDeveloper. So on oracle.com it's technology/JDev. On OTN it's otn.oracle.com/product/JDev. There you find all the materials that you need. You find references to the documentation, downloads for software, tutorials, discussion forum references, so like how to get to the Oracle JDeveloper discussion forum on OTN to discuss issues as you find them, and a lot more. The 2 pages I want to point your interest to is the ADF Insider homepage. So if you happen to get to this recording via the recommendation of a co-worker or just Google, then the ADF Insider homepage will provide you a lot of more recordings that we put more and more content onto this page as we go. Another page I want to point you to is the ADF Code Corner. ADF Code Corner is a page that is kind of in blog style, providing you sample code and documentation about advanced use cases that definitely make a lot of sense for you to have a look at and to play with. So this concludes the second part of the API mistake session, and thanks for watching.